Okay guys, here we are and we're going to continue our solar system tour. Our first stop is the sun. Here are a few pictures of the sun if you would like to read the bottom. I will zoom into that. So first take a look, pause the video if you would like. Okay, so SOHO spacecraft ultraviolet image of the sun. There is this one. So technically it's just telling you what you are seeing. Okay, so a ball of hot gas. We start our journey through the solar system at the center. Here we find a gigantic ball of gas so massive that immense pressure has ignited a fusion reaction. It is an average-sized yellow star known as the Sun. It is one of the most common type of star in the universe. Here in the cosmic fusion, hydrogen atoms under atoms, releasing a tremendous amount of energy. Scientists believe that this reaction has been taking place for about 5 billion years and will likely continue for another 5 billion years. At that time, the sun's hydrogen supply will have been depleted and heavier elements will begin to fuse. This will cause the star to swell to the size of a red giant, consuming most if the swell to the size of a red giant, consuming most consuming most if the inner planets in process. Eventually the sun will end its life as a cold, lightless body known as a black dwarf. Okay, so here are a few pictures of the sun. Here's an extreme ultraviolet image telescope. Okay, let me move this maybe just a little. Imaging telescope composite image. Extreme ultraviolet image telescope view of the sun. NASA as a sun ground-based telescope with a solar filter. Sea and sky image. So this is different. So when it said that it's from a different image, they would notice you. You see how it says NASA down there. Well, here it says from the sea and sky image. Cool. Yay, really. Solar facts. The sun is the target body in the solar system. It was a diameter of 863,482 miles. The nuclear reaction taking place with the sun dried its surface temperature to 10,832 Fahrenheit. That's really hot. Solar radiation is measured in wavelengths that include radio waves, microwaves, infrared rays, infrared, visible light, ultraviolet, X-rays, and gamma rays. Like all other bodies in the solar system, the sun rotates on its axis. Like the others, its equatorial region rotates faster. That's its polar regions. The equatorial region rotates once every 27 days, while the polar regions rotate every 34 days. Okay. Sorry. Here's a picture. And it says SOHO spacecraft image of a large sunspot group. Sunspots are cool magnetic regions on the surface of the sun. They appear darker viewed through a filter. An image of the Earth is shown from their side. So look at that. This is the size of the Earth, approximately. And if you try to fit it in there, that will probably be kind of the same size. That's really cool. And apparently, my science teacher said that the dark spots on the sun, so we're just going to go look at back in the pictures. The dark spots in the sun are actually cool spots. Well, extremely hot for us, but, you know. Features of the sun. Through the light from sun seems constant to us. The sun is far side from stable. Magnetic storms and anomalies cause a number of unique phenomena. Dark spots can sometimes been seen on its surface when viewing through a solar filter to reduce the light known as sunspots. See, they are actually parts of the surface that are several hundred degrees cooler than the surrounding areas. So as I told you, it's a lot cooler, but still hot for us. Tremendous flames of hot gas called solar flares and prominence shoot out several 100,000 miles into space. A stream of ionized particles known as the solar wind blows out into the far reaches of the solar system at speed of up to 1,000,000 miles per hour. The sun provides us with a unique opportunity to study what makes a star work. It is the only star in the universe that is close enough for us to see in the surface. Okay, so we're about to see some statistics from the sun. Let me just. Okay, so this is where I'm going to end my tour. If you want to read them, here you are. You can pause the video for now. But I'm going to tell you where our next stop will be, so you can search the video or just subscribe to me. Oopsies. Wow, okay. Oopsies. So, we are going to continue our tour to Mercury. So, right? Continue to. Okay, so this is where we're going to end.